across the board that climate change is happening and that it's accelerating and that humans are the cause.
To quantify the impacts of climate change on the winter sport recreation industry, climate change could cost over $1 billion a year.
The more we can reduce emissions today, the more of winter we can preserve for our children.
These things are being made worse by climate change. The science is there. So we are no longer talking about the future. We are talking about the here and now.
Welcome to another awesome Protect Our Winters virtual event, another edition of the Future of the Outdoor State. Thank you guys all for joining. My wonderful co-hosts are jumping on with me. Yeah, this is awesome. I don't know about you guys at home, but I'm really excited to get into some back to school vibes and kind of learn about some sciencey stuff. And before I introduce my wonderful guests, I'll introduce myself really quick. My name is Amy Ingerbetson. I'm a professional skier. I'm joining tonight from Truckee, California, which is in Tahoe in the heart of the Sierra Nevada mountains. And yeah, I'm excited to be joined by some amazing science minds and climate experts who are also avid lovers of the outdoors, but also specifically these mountains. So with that, I will welcome Dr. David Hill, professor from Oregon State University, and Dr. Ian Bolliger, who is a recent PhD graduate from UC Berkeley. So I guess I'll start off by saying congrats, Ian. And yeah, hey guys, welcome.
Hi, good to see you.
Thanks a lot.
Awesome to have you guys here. And before we get into introducing you guys, I want to let everybody watching know that we are going to chat for about 20 minutes, and then we're going to do a Q&A. So if you guys have questions while we're chatting about anything, pop those questions in the chat, and we will get to those kind of in the second part of our chat. So yeah, let's start with Ian. Ian, before we kind of tackle the science part of this discussion or the nitty gritty, introduce yourself as an outdoor lover and kind of like what you do outside or how you are part of what we call the outdoor state.
Yeah, so hey everybody, again, my name's Ian. I first and foremost am a skier, so I'm sure that resonates with a lot of you. I grew up in Seattle, and so I started skiing around the Washington State Cascades, and I started ski racing when I was young, and so that was a good opportunity to explore a lot of the mountains of the American West, and kind of fell in love with not only the Cascades, but a lot of these different mountain ranges that we get to play around in. I briefly did a very unmountainous stint on the East Coast for college, and then quickly scampered back to Seattle. Started backcountry skiing once I got back from college, and that really kind of opened up a lot of opportunities to explore the mountains even further. And so I moved down to the Bay Area for my PhD in energy and resources at Berkeley, and now spend a lot of my time up in Amy's neck of the woods in the Tahoe area and a little bit in the Eastern Sierra. I kind of split my time between Berkeley and Tahoe. I'm actually on the East Coast right now. My partner and I kind of escaped the smoke recently and made our way out to Pittsburgh, where her family is. So doing a West Coast climate talk from the East Coast, but I'll be excited to get back soon.
Well, lucky you. It's actually clear here today for once. So
yeah, so I've heard.
Yeah, what about David? David, how are you part of the outdoor state? Introduce me as an outdoorsman. We'll get to your credentials in a second.
Hello, everybody. Yeah, so I'm calling from Corvallis, Oregon, where the skies have also cleared recently, which we're very happy about. So I grew up in the very, very flat suburbs of Chicago, and there our sort of local ski hill had a vertical drop of about 100 feet, and we would go sledding on old covered landfills as the only vertical rise we could find. After college, though, I sort of started moving west, and I spent a season working at Keystone, fitting boots in a ski shop. After that, came to California, spent 5 years in the Bay Area, skiing in the Sierra, skiing in the Tahoe area. And I've now been in Oregon for over 10 years. And what I love most about Oregon is you can surf, you can kayak, you can raft, you can mountain bike, and you can ski like all in the same weekend. Volcano season here is my favorite thing. It starts in March, goes to the 4th of July some years. So it can be 80 degrees outside and you're in the garage waxing skis, getting ready to go ski Mount Adams or Mount Hood. And yeah, love it here and don't plan to leave.
That's awesome. That's awesome. Thank you, David. I think it's kind of cool that we in a lot of ways, like people wouldn't think we have a lot in common, but actually the three of us have a ton in common. So let's get on to kind of the fun stuff. Your guys' amazing credentials. Ian, I know you recently wrapped up your PhD at UC Berkeley, like I just said, and where you were or are a researcher at the Climate Impact Lab. And so tell me a little bit about how you took on this role and what you do today, what you study, and kind of what that means.
Yeah, so yeah, like you said, I work in this organization called the Climate Impact Lab, which is this kind of unique collaboration between some academic groups as well as some private sector groups. And the whole goal of the organization is to try and better understand the socioeconomic impacts of climate change. So we try and like merge the climate science, the awesome climate science that Dave and other scientists are performing, along with kind of some of the economic thinking that a lot of my colleagues are a part of. And we just try and basically blend those two kind of styles of thinking to help us better understand as the climate changes, which we're getting better and better at understanding exactly how it's changing in different areas. How can we translate that into impacts on communities around the world? So that's kind of what I focus on. I particularly look at extreme events. So some of my recent work was on hurricanes and how climate-driven changes to hurricanes impact coastal communities. Obviously, that's not as much of a West Coast event, but it kind of a lot of the methods kind of tie into the water resources side. I also did a little bit in my master's thesis on snowpack modeling and snowpack variability in the Sierra. So I kind of dipped my toe into a world that David is very well versed in, and kind of that's been where my personal passions meet the academic work.
That's really cool. And is it, you were at Tahoe Backcountry Ski Patrol as well? Yeah.
So probably like a lot. What's that?
You are, or you were?
I am. Yeah. It's a volunteer gig. So I patrol for Tahoe Backcountry, and I teach avalanche classes through the National Ski Patrol up in the Truckee area. So if any of you out there are in the area and are looking for some avalanche classes, get in touch.
Yes. Okay. Yes, everybody do. Okay, David, you're a professor at Oregon State, and you run a program there called the Community Snow Observations. And so I guess, tell us a little bit about that, your research, how you got to that place.
Sure. Yeah. So I'm a professor in the Water Resources Graduate Program here at Oregon State University, and my students and we study many different parts of the water cycle. A lot of the times we spend our time working on snowy environments in Alaska and the Pacific Northwest. And we're most interested in how snowpack processes in these areas are changing. And we primarily do computer modeling, but we also do try and get out in the field as much as we can to directly sample the snowpack as well. So the Community Snow Observations Project is a project funded by NASA, and we started this project a few years ago. The idea being to essentially crowdsource snow data from backcountry skiers, backcountry snowboarders, and other users. And then what we do with this is we take these measurements and we use them to build much better snowpack models, and also help out NASA to better understand how their snow-based satellites are working. So it's pretty cool. We got on-the-ground measurements, we got modeling, and we got remote sensing all working together. It's really quick, it's really easy to participate, and it really pays off. So if you're somebody who likes snow information, like if you're planning a trip and you're looking at snow data, that stuff doesn't just come out of thin air. So we would love for you to participate and contribute, and it helps everybody out.
That's really cool. So just like everyday random people like me going out into the backcountry can contribute to something like that.
Exactly. It's an unstructured program. Anybody who's out, if they're carrying an avalanche probe with them, they can measure the snow depth, put it in their phone, and it comes right to us.
That's amazing. That's so cool. I'm gonna have to get in on that. Then I can say I'm doing science work. I guess I am when we're doing our avalanche picks and stuff like that. But cool. So let's jump into kind of our first question. Start kind of basic, a little bit high level. And let's say I'm on a chairlift. I have 3 minutes to explain climate science to a guy next to me. What should I say? And like, what tips do you have? But like, remember that like I don't have a degree in science of any kind. Ian, you want to take it away?
Yeah, I can take a crack at it. I think before I like talk anything about the fundamentals of climate change, I think maybe a kind of a soapbox issue for me is that it's important to emphasize how well we understand the fundamentals of climate science. So as scientists, we often kind of like to talk about our latest research or kind of the state of the art, the state of the science. And I think there's a risk there that can come off as suggesting that climate science is in some way an emerging field or a new field. And really that couldn't be further from the truth. The first paper, at least that I'm aware of, that linked the Industrial Revolution to increasing greenhouse gas or to increasing atmospheric temperatures was in the 1850s. So we've known for over 160 years the pretty basic physics that underlies climate change. So we're still learning details here and there about at a high resolution how different regions are responding, and all that's really important. But I think we run the risk of making it sound like there's more uncertainty when we talk about that side of things rather than kind of the most important basic elements that we've known about for hundreds of years, and that is enough to make decisions for climate policy and climate action. So that's maybe my soapbox. Maybe that's the first minute of our short chair ride. But as far as like actual components of the science itself, I think there's kind of two questions to answer. One is, what is climate change? What is happening? And two is, how do we know this for sure? What is happening as we put more of these so-called greenhouse gases into the atmosphere? They kind of act like a blanket or a puffy coat. So the more gases that are in the atmosphere, the more heat they trap. Instead of escaping to space, it radiates back to Earth. A lot of people have heard of this. This is the greenhouse effect. And that causes kind of the main kind of first order impact of climate change, which is global warming. So average temperatures go up around the world. We're all pretty familiar with that. A consequence of this is sea level rise, of course. So as ice sheets melt and as the ocean heats up, it actually expands. And so we get rising seas. And then the third impact I like to focus on is, I mean, I work on this, so maybe it's my own bias, but extreme events. So in general, a lot of the extreme weather patterns we see are getting more frequent and more extreme. So we get, in general, most places around the world are starting to get fewer days of rain, but when they do get rain, it's more intense and it leads to more flooding. Similarly, droughts are longer and drier. So that's kind of what some people have coined global weirding to kind of go along with global warming. So these three impacts, I think, are kind of anybody you're talking to can relate to at least one of those: global warming, sea level rise, and this global weirding phenomenon. And pretty much anybody around the world can understand how that might impact their daily life.
Yeah, there's definitely some global weirding going on in Tahoe.
Absolutely.
Last 2 decades, at least the time when I've been aware enough to understand that. David, what can you add to that?
Yeah, well, I think something that's really good for people to understand is that, a lot of times the words weather and climate, they sort of get used interchangeably. And it's really important to understand the difference between those. And the difference between those has a lot to do with what you could sort of call a time scale. From year to year, we know that there's a tremendous amount of variability in our weather. We can have a really warm, dry year, and then the very next year it's cold and wet again. All right, so sometimes a little bit of confusion about, well, what's changed? I mean, any individual year is not an example of changing climate. So weather averaged over a long time, a long period, typically a few decades, is what we call climate. Mm-hmm. So if we want to look at climate change, we really need to investigate changes over those long time scales. And to make things even a little bit more complicated, we can also have pretty significant changes in weather that occur on intermediate time scales. So some people have heard of what's called an El Nino Southern Oscillation, or ENSO. And this is an oscillation in ocean temperatures that kind of causes our winters to sort of go back and forth between, kind of warm and dry or cold and wet. And this has a lot to do whether or not with our West Coast winter as being one to remember for skiing or one to forget. Currently, it's looking like we're going to have a La Nina year this year. And this kind of moves the jet stream and a lot of the precipitation north. And that's great for Oregon and Washington. A little bit less great for California. So sorry, not sorry. The weather changes from year to year, and that's your interannual variability. It changes over kind of medium time scales, these sort of oscillations which are natural, and then it changes long term over multiple decades. And that's the climate change that we want to be thinking about.
Yeah. I mean, I make the mistake of confusing weather and climate sometimes, but I know that sometimes when I talk about climate change, I get that back. And what is the aspect of it that climate change is the human element? We're the ones causing it. Because people always say there's these natural oscillations in weather patterns, but how, I think it's our kind of the difference is that we're causing this, like our things that we are doing in our world, in our industrialized world, are causing this. Which I think we'll get more to that in a little bit.
Yeah.
But so kind of moving forward, going deeper, I guess I was jumping the gun there. So I want to talk about kind of the climate change, I guess, following up with that we're seeing today impacting our backyards right now. And what we're seeing in our outdoor recreation spaces, our playgrounds and how they're being affected, like what we're seeing this moment. And I guess, David, start with you on this one.
Yeah, so I mean, if we want to talk about changes in snow, like over the past 30 years, let's say, we have to think about how we want to do that. Anecdotal statements like, "Oh, last year was amazing," that's great in terms of getting people excited about snow and such, but it's not that helpful scientifically. So we have to be thinking about actual measurements and data. And in the United States, we're really lucky because we have an amazing sort of network of snow observations out there, which we can use. And I use them all the time. Recreational users use them all the time. So we have a lot of stations in the Western United States, which are called snow telemetry stations. And these measure the depth of the snow, and they measure how much water is in the snow, which is what's called the snow water equivalent. These stations are great because they measure things every day, and we get this really nice picture of what's going on over the course of a water year. And we also have what are called snow courses. All right, a snow course is really just a single location, or it might be a transect of locations where measurements of snow depth and water equivalent are made manually throughout the snow season. People actually go out and they measure the snowpack. And they might just do this once a month because it's a lot of work to go out and manually measure the snow in these remote locations. So snow courses are a bit old-fashioned maybe, but they go back almost 100 years. And so we have this fantastic sort of long-term set of data that we can look at. So if that's where we get snow information, what matters in terms of if we're trying to quantify the snowpack or we're trying to quantify changes? I mean, do we care just about the maximum depth that was observed over a particular snow season, or do we care about how many days there was snow on the ground? I mean, both of those things are fairly important for a variety of reasons, including recreation. A lot of previous studies of changing snow have looked at the April 1st measurement of snow depth as kind of a benchmark. And there's a couple of reasons for that. First of all, snow courses only have measurements once a month, so you got to pick one of those months. And in a lot of locations, early April is kind of the time of maximum snowpack. So April Fools it is, right? So a couple of recent studies, one study of snow course data over the past 60 years over the Western United States showed that over 90% of the measurement locations, there were negative trends in the maximum snow observed. Model simulations that were part of that study also showed that from like the 1950s until today, kind of the maximum snowpack in the Western United States has lost about 30 cubic kilometers of water. And that's about how much water is existing in Lake Mead, which is the biggest surface reservoir we have in this country. So it's a huge amount of water. And another study of snowpack showed that there was a loss in the Western United States of about 1 day per year in our snow season over the past 30 or some years. So the time that we have snow on the ground is getting smaller. So one thing to keep in mind too about this is that these changes aren't uniform. All right, so things aren't the same everywhere. Oregon's different from California, and even within Oregon, things are different. And one thing that has to do with this is elevation. So let me give you an example. Like in Oregon, in the Central Cascades, we have 3 ski areas: Hoodoo, Willamette Pass, and Mount Bachelor. And these 3 places have summit elevations of about 6, 7, and 9,000 feet. So if you remember, the 2014-2015 snow season was terrible, both in the Pacific Northwest and California. Hoodoo and Willamette Pass essentially barely opened. They were only open for a few days. And Bachelor had a pretty complete season. So we can have a poor season on the slopes for what's called a snow drought reason, which is maybe a cold year but no precipitation, or a warm snow drought. And that's a season where maybe there's plenty of precipitation, but it's warm. And so these lower elevation areas are really vulnerable to that.
Wow, yeah, gosh, it is alarming, and you see that. I mean, I see that when I look I remember how winter looked when I was a kid here in the Sierras, and it does seem like the snow levels are kind of rising year by year. I'm sure we have years where it's different, but I look at the trend over the whole time. But that's scary when you think about winters losing one day each year, you know? Ian, you have something to add there?
Yeah.
I know that you kind of work in rain and snow thresholds and all that kind of stuff, so.
Yeah, absolutely. So I'll try and tie kind of what you were talking about, your observations in the Tahoe region, to what Dave said. Just that, so one study that we've done at the Impact Lab is to look at the number of days below freezing that different counties that represent different ski areas get around the country. And some of the results show us kind of what David was saying, that different areas are experiencing different impacts on their snowpacks. Elevation is a factor, like Dave said. Also location, whether they're coastal or inland ranges. So in the maritime snowpack, a lot of our snow is falling pretty close to that rain snow threshold. So right in Amy's backyard, Nevada County, which includes Truckee, what we saw is on average in the late 20th century, so like 1980s and 90s, it was getting about 40 days per season below freezing. And Nevada County includes some lower elevations than Truckee, so that's not just the city itself. But in the current climate, we're seeing about 30 days per season. So it's lost about 10 days below freezing. And obviously that means a lot when California is only getting a few big storms per year that's depositing all of our snow. And if just a few of those storms fall as rain instead of snow, that has a big impact. On the other hand, we look at a county like Summit County, which probably some of you are familiar with. There's a lot of ski areas there in Colorado. They had many more days below freezing. They're higher up as well, about 260 in the late 20th century and about 250 now. So they've lost a much smaller fraction of their total freezing days than we have here on the West Coast or in Truckee. So that's just to emphasize that these places that get snow right around the threshold are a lot more vulnerable than places that where the snow falls a lot colder. Both will see impacts, but kind of the California maritime resorts are probably the most vulnerable.
That's not good news for my Truckee and my squaw.
It's tough. It is. Yeah, I share that.
I know. And it's interesting because, yeah, sure, we always experience rain events here on the mountain. I think that's part of a maritime snowpack, and that helps with our layers and all this stuff. But it just seems like I never remember a season where the snow level stayed high the whole season the way it does sometimes now.
Yeah.
Oh man. All right. So going into the future now, if things don't change, if we don't change our, emissions and our policies and all these things to start moving to a different direction, what are we going to see? Like, what are the impacts going to be? Again, like on, all of our favorite sports, which seem to be skiing in this conversation here. David, start with you.
Yeah. I mean, thinking about the future is interesting. It's like, when you think about what the future is going to hold, we don't know because it hasn't happened yet. We don't have measurements of the future. So for us to sort of estimate what's going to happen, we have to turn to computer models, right? And snowpack models used as input, they use weather data. And so if we want to model future snow, we have to know something about future weather. Now, there's lots of different sort of scenarios that have been modeled for the future. And these scenarios make assumptions that are either optimistic, sort of medium or neutral, or pessimistic with regards to future greenhouse gas emissions. So you have to sort of pick one of those scenarios to go with. And you also have to think about, well, how far into the future do I want to model? Like mid-century, maybe, end of century, and so forth. So in Washington and Oregon, the results are pretty interesting. So you got to remember, snow is a combination of both precipitation and cold. Now, if we sort of think of a mid-century projection and kind of a middle of the roads emissions, what we see is that there are increases in winter precipitation. All right, now that sounds good, and these increases are larger as you get higher. So that also sounds good for skiing. But when you look at changes in mean winter temperatures, unfortunately, those are also going up in Washington and Oregon on the order of a few degrees centigrade. And Ian pointed out, a lot of these areas are right at that rain snow threshold, so a small change in temperature is kind of a big deal. So when we look at estimates of precipitation as snow in these future projections, we do see significant declines in the Pacific Northwest. Just as an example, Hoodoo, our low elevation ski hill in Oregon, if we kind of think of a mid-century moderate emissions scenario, the projections are that they're going to get about 50% of the snowfall that they're accustomed to getting. And if we look at sort of an end of century high emissions scenario, that drops down to about 25% of the snowpack that they're used to. And if you look at a higher elevation location like Bachelor, of course, by being higher, they're a bit more protected from those changes. And so the declines that they see are not going to be as great. So all of the trends are negative, regrettably, but we do have this elevation effect that we need to keep in mind. Ian already pointed out that other parts of the country are a little bit less vulnerable, like the Rockies. That's a pretty good location. Upper Midwest is actually a decent spot too. Their winters are so cold that the slight changes in temperature won't impact those areas as much. The Mid-Atlantic and the New England regions are pretty significantly at risk for these changes in precipitation and temperature patterns. I think the final thing I'll say is that changes in snow affect a lot of things, not just winter recreation. You know, snow provides a lot of valuable ecosystem services. If you think of snow on the ground, it's habitat for a lot of species that might den or cache food in the snow. And when snow melts, it basically helps to keep stream temperatures cool through a long spring and early summer. And that provides a lot of habitat resources for aquatic species. So the overall effect of climate change on snowmelt and stream flow is that essentially winter flows are going to be higher, summer flows are going to be lower, and we're really going to be basically flattening out the hydrographs that we see currently in a lot of rivers across the country.
Wow. I mean, I know it's all so connected, and I know, Ian, from what you said, obviously places like Tahoe are right. I mean, we don't have a couple degrees centigrade to lose or to get warmer. But maybe if you can talk to me a little bit more about kind of like the effects of that. I know that what you do is you study kind of how this involves the economy and the amazing economies that these, winter recreation hubs like support, in addition to all the agriculture and the other habitats and all that.
Yeah, I think that's an important thing to think about. Obviously, we love the recreation component. Most people who are on this call probably share that, but it's not the only thing. Like a lot of the towns that us and the people in the audience either live in or spend a lot of time recreating in, those are towns that depend on some of these winter recreation activities to support their economy. And so there's challenges there, particularly for these more vulnerable areas in how are they going to continue to support those communities if they're losing snow days, that's losing income as well. And so it's important to think not just in the context of recreation, which is important to all of us, but also kind of the sustainability of these communities. And not only does that affect them, but it also impacts our recreation. So regardless of what your motivation is, it's important to consider those impacts. I think I'd be remiss not to mention, we're talking a lot about snow here, of course, but everybody on the West Coast has fires pretty top of mind right now. Mm-hmm. And that's an additional impact that we expect to see more of as climate change continues. I think people are right to point out that some of the increase in fires we've seen recently is due to kind of decades of fire management practices, but that's clearly overlaid on top of a climate-driven trend. And so those two things are working in concert. It's not one or the other. Is it forest management versus climate? They're coming together. And as we get these longer and longer dry spells and warmer summers, that's just creating more fuel for fires. So we're expecting to see more fires. Those are obviously catastrophic and deadly in some cases, also wipe out economies of a lot of our mountain towns as well. So it's important that we're here. We mostly are thinking about snow here, but there are other climate impacts that we need to consider in the West in particular.
Well, we all know that. All of us have been trapped inside for well over a month now, not being able to bike or run or do anything outside because of the smoke situation. And it is all so connected. And I think it's so hard when we have these conversations about what we're actually seeing, what the science is telling us right now, and then what that will mean for the future if we don't change anything. It's easy to get wrapped up in doom and gloom, and like for me, I think that, it's also important to find notes of hope here, and the note of hope is that we do have science and we do have technology to apply these things. And when you talk about the economy of the outdoor space, we're talking about an economy that is over $880 billion annually strong in the GDP. And so we have to think about, us on this call, scientists and athletes and whatever, and whoever's joining in, we actually are a big group of people that are really powerful in our world. And if we come together on our common ground, which is that ground where we are recreating and I'm my best self when I'm outside. And I think everybody kind of involved with this can probably feel that. And so what we need to do is, in light of all the doom and gloom, we need to see the hope. And the hope is in us. The hope is in the community. The hope is in this outdoor state that was these 50 million people annually that partake in outdoor sports. And we need to vote. And I mean, I think you guys can attest to this, that it's about policy change. It's about coming together. It's less about individualized actions, which are really good, but we need to make our voices heard, and we need to use these tools that Protect Our Winters gives us. And they have the slogan right now is make a damn plan. It's makeadamplan.org is where you can use their tool to kind of make your plan to vote. And that's where we can find the hope in this situation. And I don't know, I know you guys kind of engage in that part as well, but I think that's where I'm here to learn, and then to learn, okay, this is why I need to, use my voice and use these tools that we're learning tonight to convince others to join in.
Mm-hmm.
So
absolutely.
Make a damn plan, everybody, right? So we're going to jump into the kind of questions part of the evening. We have a couple. If you guys have some more, feel free to add them into the chat. The first question is for Ian from Claire. And Claire would like to know, can you tell us more about how we actually know it's warming from your chairlift talk? So what data sets can you point to there?
Yeah, I think I was running on too long. I was planning on the bottom to top gondola ride, not the quick chairlift ride.
The old squaw gondola.
Yeah, exactly. Or the tram. So how do we know that it's warming? Well, we've developed more and more sophisticated measurement networks, both around the world on the ground, as well as satellite measurements. And so we've gotten better at understanding exactly how global average temperatures are changing. And the idea here is to take out a lot of the regional variability, which we've talked about before, this difference between climate and weather. When you look at the average temperature around the world, it's a lot more steady of a signal than if you look at one location in particular. Truckee could have a very warm year and a very cold year back to back. But around the world, you kind of average those differences out. So what we found is the warming that we've seen over the past decade or so is about 10 times faster than anything that was seen in the pre-industrial era. And we know this from ice cores and from other forms of measurement that can tell us how quickly temperatures changed in the past. It's absolutely true that there were natural cycles which brought the Earth's temperature up and down dramatically, but humans have never existed in those temperatures. And so we are not set up necessarily to handle them. And we're moving that needle at a much faster rate than has ever occurred naturally before.
And it seems kind of obvious, you're saying that like individual points don't matter as much, but when you hit these record highs over and over again, that's going to drive up our average really, really quickly. Like when we see so many year after year, highest average ever recorded, temperature in places like the Arctic and whatnot.
Yeah, absolutely. And that's where a lot of the work we do focusing on extremes meets this desire to get this kind of smooth climate trend, to pull this smooth climate trend out of the data. We need to recognize that different places around the world are hitting extreme new records every year. And that's kind of the most important from a societal perspective. It's these extreme, it's not the 68 degree day that's now 70 degree day. It's the 95 degree day that's now 97, which is really causing impacts, at least from a health standpoint in that case.
Wow. Okay, we have another question from Bailey. This is an open question, so either of you can take it. What advice do you have for those of us that get the question, yeah, but we had a great winter, so there's no such thing as climate change, which again factors into like, yeah, we had the coldest spring ever, there's no climate change, I get that a lot too, Bailey.
Yeah, I think that's a great question. And I think that goes back to, a little bit, both Ian and I touched a bit on this, of just trying to help people to understand the difference between these kind of like 1 year to the next changes as being a weather change, but understanding the difference between that interannual variability and this longer term change in climate, right? So just because we have one really bad year or one really good year, that data point on its own isn't the most important thing. It's tracking those over these long-term periods.
Yeah, is that really that holistic look at the long term and where those kind of graphics are going. Mm-hmm. Next question is for David. This question is from Robert. How can we get involved in community snow observations, and do you have an app? I really want to know the answer to this question.
Yeah, that's so the first the thing that you should do is just go to communitysnowobs.org, which is our project website, and all the information that you need is there. We do collect data from a couple of different platforms, one of which is the Mountain Hub app, which is an app it was a startup app from about 5 years ago that we recently acquired. So we actually own it now and are making certain changes to it. So that's the thing to do, is just go visit the website, and all the details are there, and all the data is there too. We sort of give all the data away there.
I love that. And it's so, because we're, if we're avid backcountry skiers, we have our noses in the snow anyway, looking at snow safety. And I think it's funny when you talk about the snow tells. I'm always on the snow tells trying to figure out, like, is it going to be like over the head shoot day, or should we not like bother, or like looking at those snow densities and knowing we can use that for this other purpose is really exciting. I will get on it for sure.
And I can
okay.
From personal experience, the website is great. It's very clear. I went there the day after I met Dave. It's fantastic.
Oh, good.
I'm excited to check it out. Another question, also from Robert for David, kind of piggybacking on that. Do you share this information with any avalanche centers? He says the Sierra Avalanche Center, but in any avalanche centers?
That's a good question. So all of the data that we gather, we do distribute freely. And so anybody can go to our website and access it. And we have a variety of different people that do that. With regards to avalanche centers, what I will say is that I mentioned that we collect data in multiple ways. One way that we do so is by using what's called Snowpilot. And Snowpilot is a desktop program which is favored by a lot of avalanche professionals, ski patrollers, and so on. And we are able to access data from that. So there is an exchange, and this idea of sharing data between as many people as possible that we try and stick to.
Awesome. Very good questions, Robert. Thank you. Another question from Tom, not to anyone in particular, to everybody. As you look at future climate projections, specifically snowpack levels, what socioeconomic impact studies have been authored that would show legislatures and government officials in snow tourist areas real economic impacts to their communities in the next 10 years? How can we do a better job in educating our lawmakers? Wow, Tom. Good question.
Good question. So I can speak to that a little bit, although my individual work on the socioeconomic impacts doesn't necessarily focus on these ski towns in particular. But I do know that POW has kind of supported a lot of work in this area. And I actually had no idea how substantial of an economic impact the outdoor recreation industry had until I kind of came across POW and started working with them. So I think there are a lot of resources through POW that are available to kind of identify that impact in particular. I'll just kind of give a quick plug for the type of work we do, which is not necessarily ski town focused, but what it does is it tries to target exactly what the cost is of each additional ton of carbon dioxide emitted. So that's kind of like a tricky challenge to try and say exactly how much money is it costing us in societal damages. So people dying, people not able to work as much, agricultural losses, damages from extreme events. Kind of wrapping all these numbers up into one is a number called the social cost of carbon, which is, I won't go into the details here, but it's kind of a battle point over what that actual value should be. And it matters a lot, in particular for federal legislation. So that's one of the things we work on. It's not ski town specific. But for the kind of winter recreation industry studies, I would definitely connect with POW, and I know a lot of the other Science Alliance scientists that work with POW have worked on this problem in particular.
Yeah, I think I don't have a scientific answer to that question, but through my work with POW and going to Washington with them and getting so educated with all their resources, we talk about this economic factor that is the outdoor space. And I said this kind of $880+ billion number. What's important about that number is the fossil fuel industry is actually only like $360 billion annually. And the pharmaceutical industry is somewhere in the $400 billion annual GDP growth area. And so if you look at that, you see that like that equals power. And what it is the outdoor community isn't activated. We're not political. We're not, people that have big teams of lobbyists, and we're spending all this money on policy. And that's our job, is to become activated. And there was this time where, leave your politics, leave this kind of stuff off the trail, off the chairlift. But our playgrounds, we're not going to have trails or chairlifts to leave things off of if we don't get involved and speak up, because it is a powerful voice that everybody here tonight is a part of. And so, not a scientific answer, but again, POW has those great resources, and kind of, I think it's up to us to use our voices. Another question, I think we have time for one or two more. This one's from Sarah. She says, as the fires continue, should we plan for more worst case scenarios? Like, when is the tipping point? I definitely feel you on that, Sarah.
You want to take that, David? You want me to give it a crack?
Yeah, you were talking about fires earlier, so why don't you build on that?
Yeah, it depends on what you call a worst case scenario. I think, fires are not in particular my area of expertise, but I can say that we're leaning towards larger and larger fires. So when they do happen, they're going to be bigger. There is kind of, you talked about a tipping point. I actually can't tell you what that tipping point is. There is kind of a limit, which is the more things burn, the less fuel there is for the following season. And these warmer and drier summers, we're going to see more. So that's the best answer I can give you. I don't know in particular for fires if there's a tipping point that we see, but I can say that we're already experiencing a lot of the effects. And if the worst case scenario is that much worse than what we've had this year, that's a scary thought.
That is scary for sure. It's someone said to me today, they have like disaster fatigue, and I'm like, well,
yeah,
might want to learn some more stamina, because we might not be done. Depressing. Change to a little bit more of a positive question. We have many students tonight here that are in AP Environmental Science. So what advice do you have for the next generation of scientists?
Ooh, that's a good question.
Yeah.
I would say, I mean, I would encourage people to find the thing that resonates with them. Whether that's outdoors or skiing or some of the things we've been talking about. Maybe not everyone wants to be a snow scientist, that's fine, but find something that resonates with you. That's the first thing. And then start asking questions of your teachers and other people, other adults, other colleagues, to sort of guide you towards things that you can do to start doing activities that align with that, right? So you've got to find the thing that you're interested in, and then come up with the strategy that's going to sort of allow you to sort of pursue that.
That's a good life lesson, not just for scientists.
Yeah.
Okay, our last question. Oh, do you want to jump in, Ian?
Nope, I was going to kind of echo exactly what Dave was saying. So yeah, let's get to one more. That'll be good.
Okay, last question. You are all passionate skiers. You guys, everybody listening and joining us tonight. And your careers clearly cover doing research that is honestly kind of depressing for the sports that we all live to do. So how do you stay hopeful and motivated?
I can speak for one. Yeah. So I can say a couple things, I guess. One, a lot of our research focuses on like adaptive capacity of different areas, and how much does adaptation play a role in what the future consequences will be. That doesn't say that we're able to put snow back on the mountains when it gets too warm, but it is able to say how do people adapt as they are, if they have the resources and there's the political will and the know-how in the region to be able to adapt to some of these higher temperatures, rising sea levels, et cetera. How can communities do that? And so that, I think, is the most uplifting thing. It also requires kind of the most creative thinking, because you have to think kind of for these situations that we've never been in before, how can people adjust to it? So it's a challenge, but it's also kind of uplifting to see what that human capacity is to adapt. Relatedly, I think the other thing I would mention is, actually just slipped my mind. Why don't you go, David? I promise I had a second thing.
It'll come back to you.
It'll come back to me.
Yeah, I think we should throw the final answer here to Amy. I want to hear what you got to say about that.
I mean, I think like echoing off Ian's point is just, I have hope in humanity. And when I look at climate change, I don't see it as a political problem or a science problem. I see it as like a problem for all of humanity. And I think like the possibility of when people do gather together, I call me an optimist maybe, but I think that there is hope there. And there's people, if we can take the passion that we all have for our sports and turn that into passion for these issues that we need to care about, I think there's a lot of hope there, because I know there's a lot of passion in this community, the greater community of outdoor lovers.
Yeah, and I did remember what I was going to say. It's right along those lines. It's just that there's this wide range of futures that we could realize, and yes, a lot of them are pretty bad. But a lot of them are really good, and there's a lot of aspects of society outside of climate change that are improving. We obviously have a lot of challenges as well. But if we have this agency, kind of as humanity, as a species, to cover this wide range of potential outcomes and to shift us towards the better ones, I think there's some hope in like the large potential for change, even if it's going to be very challenging. That I see going forward. So that's kind of like it's what makes me feel like this work is important, and that there is a path forward.
Yeah, like that. And I have to just personally thank you guys both so much for the important work you do, and that everybody has a role in this, and your guys' is amazing, and I appreciate it. I very much appreciate you both being here tonight, as well as I appreciate everybody who's tuned in and watched, and thank you for your wonderful questions. I hope we were in another time and place. We were supposed to do this conversation in person together. So I hope that there's time in the near future where we can redo this conversation with skis on our feet. But both Ian and David, how can people follow your work and get in touch with you guys or learn more? David?
Sure. Well, yeah, I mean, you can, I'm easy to find, David Hill at Oregon State. I'm the only one there. So you can find information about my professional work there. The Community Snow Obs website also got mentioned, and I'm on social at D Foster Hill.
And Ian?
Yeah, so you can follow the work of our group at impactlab.org. That's this broader climate impact lab organization, or rhg.com, which is the Rhodium group, or the kind of private sector arm that I work for. And then also Twitter at Ian_Bolliger. I'm pretty sure. I'm not as active as on Twitter as David. David's a Twitter expert, and Amy. But I believe you can find me there. And yeah, a quick Google should do the trick as well.
Nice. Well, I'm definitely going to follow up on both of those platforms. And I want to say that I'm doing science and I'm in the backcountry, so I'm excited about that. Of course, you guys can follow me. I'm at Amy Ski on Instagram, and I love to answer questions and chat about this stuff. And I share a lot of links and resources from Protect Our Winters there. So yeah, just thank you guys, everybody at home. Thank you for tuning in. Thank you for your questions, your support, your passion. Please make a plan to vote. If you make a plan, you're more likely to do it. Get your friends to do the same. Makeadamnplan.org. It's awesome. It's easy to remember. And yeah, to kind of wrap this whole thing up, I'm going to leave you guys with a short video that's narrated by Jimmy Chin. It's a really awesome video. And it just talks about the importance of us showing up this November. So with that in mind, thank you guys all for being here. Have a great night. And yeah, let's go.
Thank you so much, Amy. Thanks, everybody.
Thank you, guys.
If we want to protect the places we love, we must vote. America is a nation of many nations, many histories, many experiences. But despite our different paths, we all converged here. You see, our common ground is the land itself, our playgrounds, and places we love. Now we must protect them from the effects of climate change. If you love the land, make a plan to vote this November. Start your plan at makeadamnplan.org.